Refinement of crystal structure. Annealing or normalizing changes the crystal shape. Cold working of metals results in elongated or distorted crystals. Annealing or normalizing can change the crystal shape back to the original or more desirable form. That's why we use it. Now we're going to cover the different types of annealing. Types of annealing. This procedure is done to most alloy steels that are to be heated to the austenizing temperature range prior to allotropic transformation. This is done to prevent cracking of the material and thermally stabilize the part prior to rapid heating in a preheated oven. The material is usually preheated to a temperature between 1000 and 1250 degrees Fahrenheit. Full annealing. Full anneal cooling is usually performed in the furnace at a prescribed rate. The resulting microstructure is a coarse pearlite ferrite mixture. Machinists will usually appreciate machining the annealed material due to its pearlite microstructure. This material has a relative softness and great chip-breaking properties compared with tempered martensite microstructure. The pearlite grain consists of thin layers of iron carbide, which is cementite, and nearly pure iron, which, if you remember, is ferrite. When the machinist's tool contacts the iron carbide layer, it fractures, allowing the tool to proceed easily to the next carbide layer. The tool will cut through the pearlite microstructure without much difficulty and produce the desired figure 6 and 9 chips. Process annealing. This is used when time is most important. Full annealing takes a very long time, tying up your ovens, your parts, and remember that increased costs. Better than no annealing at all, process annealing removes some but not all of the stresses. Process annealing parts are heated to only 1050 Fahrenheit to 1300 degrees Fahrenheit, well below the austenizing temperature. Process annealing may be performed several times between forming and machining operations, the processes, to stress relieve the part. Process annealing is also carried out intermittently during the working of a piece of metal to restore the ductility lost through repeated hammering or other working. Page 182 in your book, figure 12-5. So process annealing can eliminate the hazard of distortion taking place after a long period of time. If you look at A, after machining or forming, the part appears to be holding at its proper dimensions. But after a long period of time, perhaps weeks, just like what you saw in the previous video, internal stresses may cause the part to distort. Process annealing the part after machining or forming will relieve internal stresses. Some distortion will be eliminated and the rest of the distortion will take place immediately. A thin final machine cut will remove the effects of this final distortion. Figure 12.3. In full annealing, steel is heated to a temperature above the upper transformation temperature before it is very slowly cooled. Figure 12.4. In process annealing, steel is heated to a temperature that is below the lower transformation temperature, and this process relieves some internal stresses without taking a great deal of time, thus saving the company spheroidizing. A quick annealing method similar to process annealing, a process for high carbon steels containing cementite. Similar to process or stress relieving annealing, the cementite is spheroidized and globular forms appear in the microscopic pattern. Parts are heated to the near lower transformation zone and slowly cooled. One note, when ferrite, low carbon steel is annealed, the globular forms do not appear. And over to figure 12.6, in spheroidizing, parts are heated to a temperature near the lower transformation temperature before very slow cooling. And you can see where that spheroidizing temperature range lies. Normalizing. Normalizing is done to return steel to the normal condition it was before being altered by cold working or other processes. Similar to full annealing, normalized steel is heated above the upper transformation temperature, which is austenized, and then cooled in still air. Does not soften, increase ductility, or remove stress as much as full annealing. Normalized parts are a little stronger, harder, but they are more brittle and have a slightly finer, smaller grain structure. When ferrite, low carbon steel, is annealed, the globular forms do not appear. Figure 12.8. Here's a chart of the normalized steel. It's first heated to a temperature above the upper transformation temperature, where it changes to austenite, and then it's taken out of the oven and just slowly cooled at room temperature by being left on a bench. And here are 4 charts for full annealing, process annealing, spheroidizing, and normalizing. And it was the past 4 charts we just went over. But here you can compare the 4 different processes. And last but not least, figure 12.10 is a handy chart for a reference of annealing, normalizing, and quenching of a material. Remember, full annealing and normalizing produces softer, more ductile, and more stress-free parts. Quenching produces parts that are relatively hard, strong, and brittle. And that concludes this portion of the lecture.